Let's take another look at probability. Only this time we're going to look at two different types of probability, or two different types of events. We're going to have an independent event and a dependent event. Let's take a look at an example. You have 4 cards with M's written on them, 2 with A's written on them, 6 with T's, and 8 with H's. From the stack of cards, you draw an M card at random. You then replace it. What is the probability that the next card you draw at random will also be an M? So you draw an M, and then you put it back. So what you need to do is you need to look at all your possibilities. 8 plus 6 is 14, 14 plus 2 is 16, 16 plus 4 is 20. So there are 20 possible cards to draw from. If you want to draw an M, you would have 4 options out of 20. Put that in lowest terms, 1 out of 5. Now let's say you draw an M card at random, but you do not replace it. So you draw an M card, and now it's no longer in the pile. That means we only have 3 M cards left, and a total of 19 because I've taken one of the M cards out. Now what is the possibility of drawing a second M card? Well, now you have 3 M's remaining out of a total of 19, and your probability becomes 3 out of 19. Each of these cases is the difference between an independent event and a dependent event. An independent event is an event which occurs and does not affect the probability of another one. So this first example in green, when we drew an M, we put it back, so it didn't affect whether or not we would draw an M the second time. Our yellow one is what's called a dependent event. The probability of both events occurring is a result of the dependence of another. The probability of the first event and the probability that after the first event, the second event will occur. So in our yellow example, we were dependent on what we drew first. For the first example, we drew an M, but we did not replace it. So that changed our probability. It was dependent on what we drew first. Let's take a look at some examples, starting with independent events. When we're trying to figure out what the probability of an independent event is, we're going to take the probability of the first event, probability of A, which we'll call the first event, followed by the probability of B, which will be our second event. Since the two are independent, we can take the probability of the first event and multiply it by the probability of the second event to get the overall probability. Here's what I'm referring to. Let's say you roll a number cube once, like a die. Then you roll it again. What is the probability that you get a 2 on the first roll and a number greater than 4 on the second? So for this example, for our first roll, we want a 2. This is our first roll. For our second roll, we want something greater than 4. So let's take a look at those two probabilities. For our first roll, getting a 2. On a 6-sided dice, there is only one side that says 2. So we have one option out of a total 6. That's our first event. For our second event, our 2, even if we roll a 2, it doesn't go away. That side doesn't cease to exist because we've rolled a die. So we still have 6 sides. 6 sides total. How many of those sides are greater than 4? 1 is not, 2 is not, 3 is not, 4 is not greater than itself, 5 is, so that's one option, and 6 is. So we have 2 of those options, which in lowest terms is 1/3. So probability of rolling a 2 is 1 over 6. Probability of rolling something greater than 4 is 1 over 3. But what is the probability of rolling a 2 on the first roll and then something greater than 4 on the second? According to this, we will take our two probabilities and multiply them. 1/6 times 1/3, and we get 1/18 is the probability of rolling a 2 and then rolling something greater than a 4. Let's take a look at another independent event, and this will be tossing a coin. Again, once we toss a coin and get heads, the heads doesn't disappear, it remains. So you toss a coin twice. Find the probability of getting 2 heads. So first toss, we want heads. Second toss, we want heads again. So in the first toss, a probability of getting heads, there's one side that has heads and 2 sides total, so it's 1 over 2. The second time we toss it, it's the same probability, 1 over 2. So let's take these two probabilities and multiply them together. And we have a 1 in 4 chance of flipping a coin and getting heads 2 times in a row. Now let's take a look at dependent events. For two dependent events, A and B, the probability of both events occurring is the product of the probability of the first event and the probability of the second event after the first one occurs. So we're going to solve this similarly to independent. The probability of event A happening and then event B will be the probability of event A. This time though, it'll be the probability of event B after we do A. So we have to do event A first. Order will matter. So let's take a look at an example. 3 girls and 2 boys volunteered to represent their class at a school assembly. The teacher selects one name and then another from a bag containing the 5 students' names. What is the probability that both representatives will be girls? So again, we're going to have 3 girls and we have 2 boys. So we want to know the probability of getting 2 girls. So the first draw, we want a girl, and the second draw, we want a girl. So there are a total of 5 people. Our first probability is 3 girls out of all 5 people. 3 out of 5. However, for the second, if we draw a girl, that only leaves us 2 girls remaining. So drawing it a second time, we're only going to have 2 girls out of a possible 4 left. Putting that in lowest terms is 1/2. So notice that our first probability is our total. We had 3 girls to start out of 5, but as soon as we drew one of those girls, she could no longer be counted. So we were left with 2 girls remaining, and that meant 2 girls plus 2 boys is 4. So multiply our two probabilities. 3/5 times 1/2, 3/10 is our probability of getting 2 girls to be drawn from the hat. Let's take a look at another example using the same scenario. We're looking at drawing names from a hat out of a total of 5 students, 3 girls and 2 boys. So this time, let's figure out what the probability of 1 boy and then 1 girl. So the probability of boy, then girl. Alright, so we've got the probability of the boy. We'll just put probability of B. Is there are 2 boys out of the 5. So that's the probability of the boy. Then the probability of drawing a girl's name. Now remember, we've already drawn a boy, so that leaves 1 boy left and 4 students total. So that means that our probability of drawing a girl next means there are 3 girls out of the 4 that are remaining. So, to figure out the overall probability, take the probability of each event. Let's multiply those together. We get 6 out of 20, or 3/10.